Okay, fourth grade. It's time for lesson 9 today. Our objective today for lesson 9 is to use the place value chart and metric measurement to compare decimals and answer comparison questions. Let's take a look at the application problem, which is on page 65 in your blue Learn books. Turn there now, please. Kelly's dog weighs 14 kilograms and 24 grams. Mary's dog weighs 14 kilograms, 205 grams. Hei-jung's dog weighs 4,720 grams. Order the weight of the dogs in grams from least to greatest. Okay, so let's start with cubes. Let's unpack the problem. Start by circling important numbers. Okay, we have Kelly's dog, Mary's dog, and Hei-jung's dog. Our first instruction is to order the weight of the dogs from least to greatest, which means we need to translate a couple of these units into similar units so that they can be compared to each other. Okay, we know that 1 kilogram equals 1,000 grams, right? So we can compare our three values in a couple different ways. Let's start with a tape diagram to represent each amount. Let's start with Kelly. Kelly's dog weighs 14 kilograms and 24 grams. Let's draw a rectangle to represent that. Okay, 14 kilograms and 24 grams is equivalent to 14,024 grams because there are 1,000 grams in a kilogram. That's Kelly's dog. Next we have Mary's dog. Mary's dog is pretty similar in weight, but we can tell with a quick comparison of these weights that Mary's dog weighs a little bit more, right? They both weigh 14 kilograms, but the additional weight, Kelly's dog only weighs 24 grams more than 14 kilograms. Mary's dog weighs 205 kilograms more. Or I'm sorry, 205 grams more than 14 kilograms. So the rectangle for Mary's dog is going to be just a little bit bigger. And that value is 14 kilograms, 205 grams. Which translates to 14,205 grams. Last, we have Hei-jung's dog. 4,720 grams. Well, if we compare that to these values, we know that that must be a very small dog compared to Mary's dog and Kelly's dog. It weighs like 1/3 the weight of the other dogs. So we would draw a very small rectangle to represent the much smaller value of 4,720 grams, which if we wanted to write it with kilograms, we would just convert every 1,000 grams to 1 kilogram. So 4,720 grams will be represented as 4 kilograms, 720 grams. So if we want to answer the question for part A, we're going to order from least to greatest. So we'll start with 4,720 grams, and it says to order the weight of the dogs. So we're writing the values, 4,720 grams, which is less than the next value, The next largest is 14,024 grams. We also need to make sure that we're answering in grams and not kilograms. We want to use the converted grams value because that's what the question asks for. And our largest value is 14,205 grams. Okay, order the weights from least to greatest. Done. Part A, done. Part B says, how much more does the heaviest dog weigh than the lightest dog? Well, we've got them ordered here. We know that our heaviest dog weighs 14,205 grams, and our lightest dog weighs 4,720. We don't need the middle dog's weight, Kelly's dog. We don't need that information, so we're just answering how much more does the heaviest dog weigh than the lightest dog. That math language tells me that we're looking for the difference, right? We're making a comparison between two different values. And in order to find the difference, we need to subtract. Starting, of course, in the ones place. 5 minus 0 is 5. Let's do a little borrowing here. $9,485 grams is the difference. Subtract carefully. Be sure to regroup as you go. And we need to answer the question, as always, in a complete sentence. How much more does the heaviest dog weigh than the lightest dog? You could say the heaviest and the lightest dog, or you could write the owner's names. You could write that Mary's dog weighs 9,485 grams more than Hei Jung's dog. Complete sentence. Make sure your problem looks like mine. Okay, let's take a look at the problem set on page 67. Let's start with number 1. We want to express the lengths of the shaded parts in decimal form. Write a sentence that compares the two lengths. You want to use the expression shorter than or longer than in your sentence. Okay, so let's look at part A. We have two different 1 meter tape diagrams with different amounts shaded. Let's write those amounts in decimal form. We know that when we have a meter separated like this tape diagram, it's divided into tenths of a meter. In part A, we have 3 1/10 sections shaded, which means that we have a value of 3 tenths shaded. In the second part, the second tape diagram in part A, we have 2 tenths shaded, and then we have a fraction of a tenth shaded. We have, if you count carefully, it's very hard, but there are 7 tenths of a tenth shaded there, which represents 7/100ths of a meter, right? These skinny little 1/100th strips there are 100 of them in the meter. So this value is 2 tenths and 7/100ths of a meter. Okay, express the shaded parts in decimal form. Write a sentence that compares the two lengths using shorter than or longer than in your sentence. I'm going to use the decimal values, but I'm going to write in a complete sentence right down here. 3/10 of a meter is longer than 27 hundredths of a meter, period. You can compare that visually. You can see that 3/10 is larger. There's a larger shaded area than 27 hundredths. You could also compare the numbers themselves. Remember that 3/10 is the same as 30 hundredths. So 30 hundredths is greater than 27 hundredths. Part B, I want you to complete and fill in yourself. You do have to do that on your exit ticket. There are 3 different values to compare. So I want you to pause me right now, complete part B by yourself, hit pause, and then unpause me and we'll go over it. Okay, part B. How many tenths or hundredths are shaded for the first meter tape diagram? We have 3/10 shaded and 1, 2, 3, 4, 5 hundredths, 35 hundredths of a meter. And our bottom value, we have 4 out of 10, 4/10 of a meter. And in a sentence, you would write that, well, you could write 35 hundredths of a meter is shorter than 4/10 of a meter, or you could write that 4/10 of a meter is longer than 35 hundredths of a meter. Part C says list all 4 lengths from least to greatest. You can again compare your shaded portions of your tape diagrams, or you can just compare the numbers, compare the values, and determine yourself which ones are smaller or larger. Our smallest value is 27 hundredths of a meter. So that will be first. We're going from least to greatest. 27 hundredths of a meter is less than 3/10 of a meter, which again is the same as 30 hundredths of a meter. 3/10 of a meter is less than 35 hundredths of a meter is less than 40 hundredths of a meter, or 4/10 of a meter. Okay, take a minute to make sure your paper looks like mine. Okay, number 2, I'm sorry, 2A. Examine the mass of each item as shown below on the 1 kilogram scale and put an X over the items that are heavier than the avocado. I like this problem because the first thing you need to do is tell me which one of these fruits is the avocado. It's this one. That's what an avocado looks like. Now we just need to compare the weights, and you need to put an X over anything that is less than 2/10 of a kilogram. Okay, this is 1/10 and 2 hundredths. That's less. This is 6/10. That's 3 times as much. And this is 6/10 and 100. So only the apple weighs less than the avocado. The bananas and the grapes weigh much more. Turn the page, please, to page 68. Express the mass of each item on the place value chart. Now we still need our information from the previous page. Okay, avocado, apple, bananas, grapes. None of them have a digit in the ones place. They're all 0 point something in their weights. None of them have a digit in the ones place. So in the ones place, we'll have zeros for all of our fruits. Avocado has a 2 in the tenths place. And nothing in the hundredths place. The apple has a 1 in the tenths place and a 2 in the hundredths place. Bananas have a 6 in the tenths place. And the grapes have a 6 in the tenths place and a 1 in the hundredths place. So this is just really just a place value chart for you to organize your decimal values. Fill in here and tell me heavier or lighter than. Pause me and do that now, okay, for part C. Hit pause and tell me, complete those sentences for me. The avocado is blank than the apple. Heavier. A bunch of bananas is, oops, forgot that. A bunch of bananas is lighter than a bunch of grapes by only 1/100th of a, what are we talking about? A kilogram, right? But still, it is lighter. A bunch of bananas is lighter than the bunch of grapes. Number 3, we need to do a couple things. It's like a 3 or 4 part problem here. Pay attention, especially when we get down here and start comparing the values with symbols, because that's what you're doing for number 2 in your exit ticket. Record the volume of water in each graduated cylinder on the place value chart below. A through F. We need to read each one carefully and log their values here. A, 6/10 of a liter. 0 in the ones place, 6 in the tenths place. Part B, 3/10 of a liter. C, 9/10. D, 9/10, 7/100. E, 1/10, 9/100. And F, 4/10, 8/100. Same information written in a place value chart. Now compare the values using greater than, less than, or equal to. 9/10 is greater than 6/10. Now these can be a little tricky here where we have 2 digits to look at versus 1, but really you need to look at the tenths place first. If this is 4 in the tenths place, which is less than 6, nothing that comes after the 4 can make its value so it's greater than 6/10 or even 5/10. It will always be less than 5/10. So 48/100 is less than 6/10, and 3/10 is greater than 1/10 and 9/100. That's what you'll be doing in your exit ticket. Part D says write the volume of water in each graduated cylinder in order from least to greatest. Look to your chart. That'll be the most easy way to compare them. Start with 19/100 is less than 3/10. And we're talking liters here. Let's write liters. 3/10 is less than 48/100 is less than 6/10 is less than 9/10 is less than 97/100 liter. Take a minute to make sure your paper looks like mine. Look back to these pages when you're working on your exit ticket tonight. And if you have any questions, let me know. See everybody tomorrow. Nice work.